Imagine a single object, defying every law of physics we thought immutable, threading a corridor between Earth and the Moon at a speed no natural body could survive. 7 hours ago, every trajectory model at NASA's Near-Earth Objects Center was forced into calculations they were never designed to perform. Instruments from the Parker Solar Probe, enduring temperatures exceeding 1,300 degrees Celsius, transmitted telemetry so unprecedented that even NASA's Goddard Space Flight Center had to reboot their systems twice before accepting it. In the following minutes, the Solar Dynamics Observatory confirmed anomalies that cannot be explained by any existing model of astrophysics, thermodynamics, or orbital mechanics. The object in question, known as 3-2 Atlas, entered the Sun's corona, passing through an X9-3 class solar flare, one of the most powerful flares recorded without disintegrating. Instead of being vaporized, it absorbed the flare's energy and doubled its velocity, converting the solar plasma into propulsion. It then fired a coherent laser pulse at the exact coordinates of the Arecibo Observatory in Puerto Rico, replying to humanity's famous 1974 message. Now, 3-2 Atlas is moving inbound toward Earth at 0.08% the speed of light, precisely threading a path between our planet and the Moon that it will reach in just 38 hours. To appreciate the impossibility of this feat, consider the energy of an X-class solar flare at the Sun's corona. At these distances, the plasma surrounding the flare reaches 20 million degrees Celsius, fully ionizing hydrogen and producing particle flux lethal to any known material. Yet the Parker Solar Probe and Solar Dynamics Observatory data revealed something extraordinary. 3-2 Atlas did not experience an outward blast. Instead, the object's surface temperature actually dropped for 12 seconds during the flare, absorbing energy in a controlled endothermic process and converting it into directional kinetic thrust. This defies the second law of thermodynamics as applied to natural systems. No natural object absorbs 20 million degree plasma to propel itself faster, colder, and stronger. Spectral analysis confirms the object is nuclear-powered. Its emission spectrum shows technetium and promethium, two short-lived radioactive elements that do not occur naturally in comets, asteroids, or planetary bodies. Technetium 9-8 decays. In 4.2 million years, any primordial isotope would be long gone, and promethium has no stable isotopes. Their presence proves that controlled nuclear fission is operating inside 3-2 Atlas in real time, producing detectable radioactive products. Combined with the near-complete absence of carbon, the spectral data describe not a natural nucleus, but a metallic crystalline structure engineered for purpose, a nuclear-powered object built to withstand extreme environments. The mechanism allowing this feat is equally astonishing. The Meissner effect, where superconducting materials expel magnetic fields when cooled below a critical temperature, provides the means. If 3-2 Atlas is a room temperature superconductor on this scale, the solar flare's magnetic fields are not destructive, they are channeled, accelerating the object along magnetic rails with near-perfect efficiency. It literally surfs the sun's magnetic field, converting the flare's energy into motion without friction, heat transfer, or structural stress. 10 minutes after the flare, the object stopped almost instantaneously from 0.04% the speed of light to near zero relative to the sun, hovering for 18 seconds before firing another directed laser pulse toward Earth. That pulse, lasting just 1.6 milliseconds, contained a prime number sequence from 2 to the largest known prime and a star chart pointing to Proxima Centauri, 4.24 light-years away. The star chart serves as a navigational reference, but the following pulse packets are not primes, They are spectral scans of Earth's atmosphere, revealing oxygen levels, industrial emissions, and the electromagnetic signature of a technologically active civilization. 3. 2. Atlas has been reading us as it approaches, not passively, but actively, embedding a real-time assessment into each pulse. The question now is not whether it intends to make contact. The pulse rate is accelerating as it closes distance, a deliberate handshake protocol optimizing data transfer. It's not urgency, it's precision. 3.2. Atlas is sending a message, carrying an evaluation, and preparing to arrive in the Earth-Moon corridor in 38 hours. What it will deliver, whether it is the message itself or the messenger, remains the defining question of this encounter. Continuing from the same point, the behavior of 3.2 Atlas during and after its solar interaction provides further clarity on why its survival and acceleration cannot be explained through any known natural process. The absorption of an X9-3 class solar flare was not just a survival event, it functioned as a transformation of energy into motion, suggesting an internal system capable of converting extreme thermal and electromagnetic input into controlled propulsion. In standard astrophysics, an object exposed to such conditions would either vaporize or fragment due to the intense radiative and particle pressures. Instead, this object demonstrated the opposite response, using the flare as a source of energy to increase its velocity. The data collected during this phase shows that the surrounding plasma environment did not behave as expected. Instruments from the Solar Dynamics Observatory recorded a localized 14% collapse in both magnetic field strength and plasma density at the exact coordinates where 3.2 Atlas intersected the flare. This is not consistent with the outward expansion typically associated with explosive solar events. Rather than being pushed away or disrupted, the plasma appears to have been drawn inward, suggesting that the object interacted with the magnetic environment in a way that altered the local field configuration. Simultaneously, particle detectors aboard the Parker Solar Probe observed high-energy protons moving toward the object rather than dispersing outward as they normally would in a solar flare environment. This inward flux is significant because it indicates that the object did not simply withstand the incoming energy, but actively influenced the trajectory of charged particles in its vicinity. The behavior is consistent with a system that can manipulate or align with magnetic field lines, effectively using them as conduits rather than obstacles. Thermal measurements further reinforce this interpretation. Upon direct contact with plasma at temperatures exceeding 20 million degrees Celsius, the surface temperature of 3.2 Atlas decreased for a measurable duration of approximately 12 seconds. This cooling effect under extreme heat exposure is not compatible with passive thermodynamics. In conventional systems, exposure to such conditions results in rapid heat transfer into the material, increasing internal energy and leading to structural breakdown. Here, however, the object exhibits an endothermic response, absorbing heat energy and redirecting it internally rather than allowing it to accumulate as thermal stress. On Earth, endothermic reactions exist in limited chemical processes, but none operate at the scale or efficiency required to convert such extreme energy inputs into directed kinetic output. The conversion observed here implies a mechanism capable of channeling absorbed energy into propulsion with a level of efficiency that far exceeds any known engineering system. This behavior also aligns with the object's acceleration following the flare, indicating that the energy absorbed was not only contained, but actively utilized. Spectral analysis conducted after the flare event provides additional evidence that distinguishes 3.2 Atlas from natural bodies. Observations made by the KK Observatory identified the presence of technetium and promethium within the object's emission profile. These elements are notable because they have no stable isotopes and do not persist in natural environments over geological timescales. Technetium, for example, has a longest-lived isotope with a half-life of approximately 4.2 million years, meaning any primordial presence would have decayed long ago within the 4.5 billion year history of the solar system. The detection of these elements indicates ongoing nuclear processes. Technetium and promethium are typically produced through controlled nuclear fission reactions or specific decay chains in reactor environments. Their presence in detectable quantities suggests that internal nuclear activity is not only present but actively sustained. Combined with the absence of carbon in the spectral data, the composition of the object does not align with known cometary or asteroid material, which typically contains carbon-based compounds as a fundamental component of their structure. Instead, the data describes a metallic crystalline system that operates under conditions consistent with engineered materials rather than naturally formed aggregates. The lack of organic signatures, combined with the presence of fission products, supports the conclusion that the object functions as a nuclear-powered structure rather than a remnant of planetary formation or a fragment of a larger celestial body. The interaction with the solar corona also highlights a key physical principle that appears to be leveraged by the object, the Meissner effect. In superconducting materials, magnetic fields are expelled from the interior when the material is below its critical temperature. If 3-2 Atlas operates as a large-scale superconducting system, then the intense magnetic fields present in the solar corona would not penetrate its interior, but instead be redirected around it. This would allow the object to effectively ride along magnetic field lines, using them as a form of guidance system rather than experiencing them as destructive forces. In this configuration, the solar flare does not act as a hazard, but as an energy source that interacts with the object's magnetic environment. The combination of superconductivity and magnetic field alignment enables a mode of motion that resembles magnetic levitation on a cosmic scale. Rather than resisting the environment, the object integrates with it, converting external magnetic and plasma en ray into controlled acceleration. At this stage of observation, the behavior of 3-2 Atlas demonstrates a consistent pattern. It does not merely endure extreme conditions, it utilizes them. The solar flare, the magnetic field, and the surrounding plasma are not obstacles but components of a system that the object appears designed to exploit. This marks a transition from passive survival to active energy harvesting, reinforcing the conclusion that the object operates through mechanisms that remain outside the scope of known natural astrophysical processes. Following its interaction with the solar corona, 3-2 Atlas demonstrated a level of control over its motion that further distinguishes it from any naturally occurring object. At approximately 4:22 UTC, just minutes after completing its energy absorption phase, the object executed a rapid deceleration, transitioning from roughly 0.04% the speed of light to near zero relative to the Sun in just 4.2 seconds. This change was not gradual, nor did it follow the expected profile of gravitational braking or drag-induced slowdown. Instead, the deceleration occurred almost instantaneously, implying the application of a force or internal mechanism capable of counteracting its momentum with extreme precision. In known physics, a sudden reduction in velocity of this magnitude would generate forces that exceed the structural limits of all known materials unless those forces are distributed or mitigated through specialized mechanisms. No external thrust plume, exhaust signature, or interaction with surrounding matter was detected during this event. This indicates that the deceleration was achieved without conventional propulsion systems, suggesting either internal redistribution of momentum or interaction with fields not directly observable through standard instrumentation used by agencies such as NASA and ESA. Following this rapid deceleration, the object entered a brief period of complete stability, hovering relative to the Sun for approximately 18 seconds. During this interval, no significant movement or oscillation was recorded. The absence of drift or instability suggests that the object can maintain precise positional control even in the dynamic environment near the Sun, where gravitational gradients and plasma flows would normally introduce perturbations. This stability further reinforces the idea that the object is not passively influenced by external forces, but actively maintains its state through internal regulation. After this stationary phase, 3-2 Atlas initiated another directed energy transmission. This time, the emission was not simply a sequence of mathematical constants, but a more complex structured signal. The pulse, lasting approximately 1.6 milliseconds, was directed toward the ionosphere above the coordinates of the Arecibo Observatory site in Puerto Rico. This location is historically significant due to the 1974 Arecibo message, one of humanity's earliest deliberate attempts to transmit information into space. By targeting the same geographic coordinates, the object's transmission establishes a direct spatial and symbolic connection to that prior communication. The content of the pulse consisted of a prime number sequence extending from 2 to the largest known prime number, encoded alongside a star chart. The star chart, when decoded, points to Proxima Centauri, located approximately 4.24 light-years from Earth. This star is the closest known stellar system to our own and has been the subject of extensive study due to its proximity and the presence of at least one confirmed exoplanet within its habitable zone. The inclusion of both prime numbers and a star chart within the same transmission suggests a dual-purpose message. Prime numbers are often considered a universal mathematical language because they are independent of cultural or biological context. Their use in this signal provides a clear, unambiguous sequence that can be recognized by any technologically capable observer. The star chart, on the other hand, introduces spatial information, linking the mathematical sequence to a physical location in space. Together, these elements form a structured message that conveys both abstract and concrete information. Shortly after this transmission, 3-2 Atlas resumed motion. Using the Sun's magnetic field lines as a guiding framework, it increased its velocity by effectively doubling its previous speed. The trajectory was adjusted with a precision of approximately 0.004 degrees, a level of accuracy that indicates controlled navigation rather than passive orbital drift. This adjustment placed the object on a path toward Earth, specifically along a corridor that will bring it between Earth and the Moon within an estimated 3-8-hour window. The ability to use magnetic field lines as a form of propulsion or guidance aligns with earlier observations related to superconductivity and magnetic interaction. By coupling its motion to the structure of the solar magnetic field, the object appears capable of converting environmental field geometry into directional movement. This method eliminates the need for conventional propulsion and allows for efficient acceleration without observable exhaust or reaction mass. In addition to its change in velocity and trajectory, the object's communication pattern also evolved. The interval between transmitted pulses began to decrease over time, shifting from approximately 0.9 seconds between pulses to shorter intervals. This compression of transmission timing is not consistent with simple Doppler effects alone, which would produce relatively minor frequency shifts based on velocity. Instead, the change appears to be an intentional adjustment in transmission rate, suggesting that the object is actively modulating its communication as it approaches Earth. This behavior is analogous to communication protocols used in engineered systems, where transmission rates increase as signal quality improves. In this case, as the distance between the object and Earth decreases, the effective bandwidth and signal clarity increase, allowing for higher data throughput. The observed increase in pulse frequency suggests that the object is adapting its communication strategy in real time, potentially to maximize the amount of information transmitted during the remaining approach window. At this stage, the observations collectively indicate a system that is not only capable of surviving extreme astrophysical conditions, but also of executing precise mechanical maneuvers, directing energy transmissions, and adapting communication patterns dynamically. Each of these behaviors contributes to a consistent profile of controlled operation, reinforcing the interpretation that 3.2 Atlas is functioning as an active system with navigational, energetic, and communicative capabilities operating in coordination. As the approach of 3.2 Atlas continues, the nature of its transmissions has shifted from isolated signals into an increasingly structured and information-dense stream. After the directed pulse toward the ionosphere above the Arecibo Observatory site, subsequent data packets began to reveal not only mathematical sequences, but also layered content that appears to serve a diagnostic and observational function. This transition suggests that the signal is not a single message broadcast, but an evolving communication sequence that adapts as proximity to Earth decreases. The most recent transmissions include embedded spectral data corresponding to Earth's atmosphere. These scans identify absorption lines associated with oxygen, particularly around the 0.76 micrometer band, which is commonly linked to photosynthetic activity. Alongside this, the signal contains measurable signatures of industrial emissions, including elevated concentrations of carbon dioxide, methane, nitrogen oxides, and sulfur dioxide. These values are not presented as raw measurements alone, but appear to be structured within the transmission as interpreted datasets, indicating that the source is actively analyzing Earth's atmospheric composition in real time. The inclusion of these atmospheric markers demonstrates that 3.2 Atlas is not only capable of emitting signals, but also of receiving and processing environmental data at a level consistent with remote sensing technologies. This implies the presence of instrumentation capable of spectroscopic analysis across multiple wavelengths, similar in principle to systems used by Earth-based and orbital observatories such as those operated by NASA and international partners. However, in this case, the sensing appears to be integrated into the object's own transmission system, allowing it to continuously update its dataset with each pulse cycle. The pulse rate itself continues to accelerate as the object closes distance. Initially measured at intervals of approximately 0.9 seconds, the transmissions have compressed to 0.5 seconds and are now approaching 0.4 seconds between pulses. This change is not fully accounted for by relativistic Doppler effects alone. While Doppler compression does occur as objects approach an observer at high velocity, the magnitude of the observed interval reduction exceeds what would be expected from a velocity of 0.08% the speed of light. This indicates that the object is actively increasing its transmission frequency rather than passively shifting due to motion. In communication systems, such behavior is consistent with a handshake protocol where transmission rates are adjusted dynamically to optimize data exchange as signal latency decreases. As 3.2 Atlas approaches Earth, the signal path shortens, allowing for more frequent exchanges and higher data throughput. This suggests that the object is not simply broadcasting information, but engaging in a structured communication process that adapts to the conditions of the link between transmitter and receiver. Another important element of the transmission is the repeated inclusion of reference data tied to Proxima Centauri, the nearest known stellar system to our own. The star chart embedded in the earlier pulse identifies this location as a coordinate of interest, potentially serving as a navigational waypoint or reference point within the broader context of the message. Proxima Centauri is approximately 4.24 light-years from Earth and hosts at least 2 confirmed exoplanets, including Proxima b, which lies within the habitable zone of its star. These characteristics make it a scientifically significant system, both in terms of proximity and potential for planetary environments. The presence of this coordinate within the transmission raises the possibility that it is being used as a shared reference point rather than a destination. In navigation and communication systems, known reference coordinates are often used to establish orientation or calibration. By including a recognizable stellar location, the transmission may be providing a frame of reference that can be independently verified by any observer capable of identifying that system. At the same time, the continuous atmospheric scanning of Earth suggests that the object is building a real-time profile of the planet's environmental and technological state. The combination of biological markers, industrial emissions, and electromagnetic signatures indicates that the scan is not limited to passive observation, but is capturing a comprehensive snapshot of Earth's current conditions. This includes evidence of technological activity across multiple frequency bands, from radio and microwave transmissions to optical emissions detectable from space. This level of integrated sensing and communication implies that the object's approach is not blind or exploratory in a general sense, but informed by ongoing data collection. Each transmission appears to contribute to a cumulative dataset that refines its understanding of Earth as it moves closer. The increasing pulse frequency, combined with the addition of environmental data, suggests that the communication is becoming more detailed as the object approaches a point where direct interaction may be possible. At this stage, the evidence indicates that 3-2 Atlas is operating with a dual function, maintaining a communication channel while simultaneously conducting a detailed assessment of its target environment. The structured nature of its transmissions, the inclusion of physical constants, spatial coordinates, and atmospheric data all point toward a coordinated system of information exchange. As the object continues its approach, the increasing density and precision of its signals suggests that the final phase of this sequence will involve the highest rate of data transmission yet observed, potentially culminating in a final, high-resolution exchange at closest approach. As 3-2 Atlas continues along its trajectory between Earth and the Moon, the focus of analysis shifts from its motion and transmissions to the broader implications of its interaction with near-Earth space. At a distance comparable to the lunar orbital radius, the object's presence introduces measurable perturbations across multiple physical systems, even without direct impact. These effects arise from its mass, velocity, and the way it interacts with surrounding magnetic and plasma environments. One of the most immediate influences is gravitational. While the object's estimated mass is significantly smaller than that of the Moon, its rapid passage and proximity create a time-varying gravitational field that can introduce subtle but detectable tidal effects. These perturbations are not sufficient to cause large-scale structural changes on Earth, but they are large enough to be observed in sensitive systems such as ocean tide gauges, satellite orbital parameters, and precise timing networks. Agencies such as NASA and ESA routinely monitor such variables, and deviations from predicted values during the approach window would provide empirical evidence of the object's influence. In addition to gravitational effects, the object's interaction with Earth's magnetosphere becomes increasingly significant. The magnetosphere, a region dominated by Earth's magnetic field, normally acts as a shield against charged particles from the solar wind. As three